Okay, so finally I managed to couple this thing together. So this is a Raspberry Pi 4, I think, which is connected to a speaker, and I have this IR receiver on this. This IR receiver is for the, what is this, a remote control. And the trick is that I use a timer. So I could just have the Raspberry Pi run all the time and use some kind of Linux tricks to start it up when I want to, start a process I want when I want to, or I can use this little thing here which I can set up to turn on every morning on weekdays, and when it does, the Raspberry Pi will boot up and it will start playing music based on a Python program that I wrote that takes into account my listening habits and will create a playlist dynamically while listening to music. So let's take a look at that. So what we have here is a desktop entry file, as you can see, which I put in .config/autostart. So this application will be auto-started, and the important thing is that, well, I say it's terminal equals true, so it should be run in terminal, and then it runs bash, which is the default shell on the Raspberry Pi OS, and it will run this script in the shell. So this is, of course, my home directory, and the alarmclock.sh shell script is in there. Everything else, like it's an application, and this is the name. So let's see what's in this alarmclock.sh. Okay, so in the top we have the shebang that this is a bash script. Then it will let this whole thing sleep for 15 seconds. So this 15 seconds is used to synchronize the playlist, because I use multiple computers where I play the music and they share the playlist. So this program is constantly gathering my, the played songs to be able to use it as the suggestions in the future. Then it starts MPD. So after MPD is started, just after a little more sleep, I will clear the MPD playlist. So the program itself should clear the MPD playlist when it shuts off, but maybe for some reason the Raspberry Pi did not power off gracefully, and the MPD in that case would just continue playing whatever was played before. So it is a good idea to clear the playlist and then rescan, because also the music library is being shared between computers. So if a song have been deleted or a new song have been added, the MPD database should be refreshed based on that, and this is what happens here. And after 2 more seconds of sleep, it will start the autoplay script. So first we change directory into the folder which this autoplay script is placed in, and then we will invoke this Python script with -- alarm clock, and I want both the standard error and the standard output to be written into this log.txt, because in that case, if anything goes wrong, this log.txt will be synced to the other computers, so I will be able to check what was the problem without having to bring the Raspberry Pi to my desk and connect it to the display and things like that. And so this end will ensure that once the program expired and it stopped running, then the next command will be executed, and that is to sleep 25 seconds at the end. That should ensure that after the program turned off, the playlists, everything have been saved. There is some time for us to sync that to the other places, and then the system will power off itself. But of course, once the Raspberry Pi powered off, it's actually, for example, the fan that is connected to the GPIO ports will still be running. So that's why my little timer in the wall socket will also have to just power off later. So basically I set it up that the power turns on in the wall socket by the time I want to wake up, and then maybe 2 hours later it will turn off. But by that time, the script will be stopped running, because I can use the the remote controller actually to shut off this Python script. So let's take a look at that next. Okay, so this script, the Python script itself, is available in my GitHub in music-autoplay, and the current version is actually, I have this develop branch which is a little bit ahead of main, and where is it? Autoplay.py is the main part, and I don't have to run it with the Python 3 command because I put the shebang /user usr/bin/env python 3 in the beginning of this file, and it is also executable in the file system, so I can run it directly from the script. I don't have to invoke Python 3 to do this, and well, you can take a look what it does. Basically, this project is, let's go back here. So we have multiple files which will handle multiple things. So there is one handling the music database. There is one that is creating a user interface for if you want to use it on your computer. So of course on the Raspberry Pi, it is not connected to a user interface or like a display. So this user interface is not shown, but it exists. We have an IR receiver for handling the remote controller, and the music handler is basically what tells MPD what to do and organizes the playlist, things like that. We have an engine.py or engine.py Python file which will handle everything basically. This is the engine, this is the back end of the whole software, or basically this is where I put all the basic functionality, I guess. We have an MPD wrapper, so we can control MPD from Python, and there are some other things here that I was just experimenting with, but haven't really got far with. So this is, I think, one of the interesting things, and maybe I should do a video on how I handle the IR receiver. So if you are interested in that, leave a comment down below. This I wrote based on someone else's code, but basically I almost rewrote the whole thing because I had a different kind of concept I wanted to achieve. But basically we have like a threaded application, so the IR receiver is always being listened to, and we put whatever it receives into like a queue somewhere, and this queue can be read periodically from the main application, but that's basically what it does. But this thing here, what we have in this IR receiver part, it strictly only handles the messages that you receive from your well, for that, first you need this XML file that will contain the remote controller's command codes and some commands that the application will be able to use. So for example, I use the cross, or what is it, the pound sign, the hash sign on the remote controller, and when that hash sign is pressed, this is the code that is received by my Python script, and that will initiate the shutdown of the music player. Or we have the OK button, which will play or pause the music, and the right button will go to the next song, and the up button will increase, or the volume down button will decrease the volume, things like that. But this is handled, so these commands are handled by a different part of the script. These codes are the ones that are understood by the IR receiver part of the script. But anyways, this is what I wanted to talk about. So this is what I made with my Raspberry Pi. So if you find this interesting, give me a like. If you want to know more about this project, maybe you want me to go through some parts of it, how it works, you can leave a comment down below or follow me on socials and interact with me. And if you want to see more videos, subscribe to the channel, and I will see you next time. Bye bye.